For most of human history, we assumed our solar system was a universal blueprint. Rocky planets close to the sun, gas giants farther out, icy bodies beyond that. Everything arranged in a neat gravitational choreography. It felt logical, almost reassuring. When astronomers began searching for planets around other stars, many expected to find similar systems repeating across the galaxy. Instead, what they found shattered that assumption almost immediately. The first confirmed exoplanets were not gentle Earth-like worlds or distant Jupiter analogs, but massive gas giants orbiting extremely close to their stars, completing an orbit in just a few days. These so-called hot Jupiters were blisteringly hot, whipped by intense stellar radiation, existing in regions where traditional models insisted giant planets should never form. According to older theories, gas giants needed the cold outer regions of a system to accumulate thick atmospheres of hydrogen and helium. Yet here they were, enormous, unstable-looking worlds clinging tightly to their stars, as if gravity itself had rewritten the rules. The existence of these planets forced astronomers to consider something radical: planetary migration. Perhaps these giants formed far away and then spiraled inward over millions of years, reshaping their entire systems in the process. If that is true, then countless other worlds may have been destabilized or destroyed during those migrations. Entire planetary systems could have experienced violent gravitational chaos, with worlds colliding, being flung into deep space, or consumed by their stars. The quiet stability we observe in our own solar system might not be typical at all. It could be an exception rather than the rule. This realization changed not only how we think about planets, but how we think about cosmic survival. Then came planets that seemed physically impossible. Some were so large yet so low in density that they appeared almost inflated, like cosmic balloons. These super-puff planets are bigger than Jupiter, but incredibly light, with atmospheres so extended and diffuse that they challenge our understanding of atmospheric physics. How can a planet hold on to such a thick, bloated atmosphere without it being stripped away by stellar winds? Others were discovered orbiting dangerously close to red dwarf stars, enduring powerful radiation bursts that should have torn their atmospheres apart long ago. And yet they persist. It is as though nature continually experiments with planetary design, producing outcomes that our equations struggle to predict. Even more surprising were planets discovered in extreme orbital configurations. Some follow highly elongated paths, swinging wildly toward their stars before racing back into distant darkness, experiencing dramatic temperature swings within a single year. Others appear locked in gravitational resonances with neighboring planets, moving in intricate patterns that resemble cosmic clockwork. These systems are delicate yet stable, chaotic yet precise, revealing that gravity can create complexity beyond what early astronomers ever imagined. The deeper we look, the clearer it becomes that our solar system is just one arrangement among billions, and perhaps not even the most interesting one. And then there are the loners. The rogue planets drifting freely through interstellar space, unbound to any star. These wandering worlds may have been born in planetary systems only to be violently ejected during gravitational upheaval. Cast into the abyss, they travel alone through the cold darkness between stars. At first glance, they seem like frozen, lifeless relics. But some scientists speculate that if such a planet retained a thick hydrogen atmosphere, it could trap internal geothermal heat, potentially maintaining subsurface oceans for billions of years. The idea that life, if it exists, could survive on a world without sunlight challenges one of our most basic assumptions: that stars are essential for habitability. In the vast silence of interstellar space, entire planets may drift unseen, carrying secrets we have not yet imagined. With every new discovery, the universe appears less orderly and more imaginative. Planets are not simply byproducts of star formation. They are dynamic, evolving worlds shaped by violence, migration, resonance, and survival against overwhelming forces. The early belief that planetary systems would mirror our own has given way to something far more humbling. The cosmos does not follow a single template. It experiments. It collides. It rearranges. And in doing so, it reveals that the concept of what a planet should be may have been far too limited from the start. If the first wave of discoveries shattered our expectations about planetary formation, the next wave completely transformed our understanding of planetary environments. Some of the most mysterious planets ever found are not just different from Earth. They seem to belong to entirely different categories of reality. There are worlds orbiting so close to their stars that their surfaces reach temperatures hotter than molten lava, where entire hemispheres may be covered in oceans of liquid rock. On these infernal planets, metals can vaporize into the atmosphere, forming exotic clouds that later condense and fall back down as metallic rain. Winds howl across their surfaces at thousands of kilometers per hour, redistributing unimaginable heat from the permanent day side to the endless night side. Many of these worlds are tidally locked, meaning one hemisphere eternally faces the star, while the other remains trapped in perpetual darkness. The contrast between the two sides can be extreme, one glowing like a furnace, the other frozen in shadow, creating atmospheric dynamics unlike anything in our solar system. Yet even among these fiery giants, there are planets that seem designed to defy logic. Some ultra-hot exoplanets are so intensely irradiated that their atmospheres expand dramatically, stretching far into space like glowing halos. Others orbit red dwarf stars, which are smaller and cooler than our Sun but notoriously volatile. These stars unleash powerful flares capable of stripping atmospheres away over time, bombarding nearby planets with radiation. And still, some of those planets appear to endure, clinging to their thin gaseous envelopes as if protected by mechanisms we do not yet fully understand. The question lingers: how resilient can a planet truly be in the face of stellar violence? Then there are the water worlds, planets that may be entirely covered by vast global oceans, hundreds or even thousands of kilometers deep. Unlike Earth, where oceans rest upon solid crust, these planets might have no continents at all. Beneath their endless waters, the pressure would increase to unimaginable levels, compressing matter into exotic forms. Layers of high-pressure ice could form beneath the oceans, separating liquid water from the rocky core below. In such environments, chemistry would unfold under conditions completely foreign to us. If life were to arise there, it might evolve in isolation from any landmass, any sky as we know it, existing in a world where the horizon is nothing but water, stretching infinitely in every direction. These ocean planets challenge our concept of habitability, expanding it beyond Earth-like surfaces to include environments we are only beginning to comprehend. Darkness too defines some of the strangest worlds ever discovered. Certain exoplanets are so dark that they reflect almost none of the light that hits them, absorbing nearly all radiation into their thick, heat-trapping atmospheres. They appear as silhouettes against the brilliance of their stars, like cosmic voids drifting through space. Scientists suspect that exotic atmospheric chemistry, perhaps clouds rich in vaporized metals or complex carbon compounds, may be responsible for their near-total absorption of light. These planets blur the line between object and shadow, forcing astronomers to detect them through subtle gravitational effects rather than visible reflection. Among the most visually surreal are planets orbiting binary star systems. In these systems, two stars circle each other while a planet orbits both, tracing a path through constantly shifting gravitational forces. From the surface of such a world, if one could stand there, twin suns might rise and set in dramatic arcs across alien skies. Shadows would overlap and stretch unpredictably. Seasons might behave in ways that defy terrestrial logic. For years, scientists questioned whether such configurations could remain stable over long timescales, yet observations have confirmed that many do. Gravity, once thought to demand simplicity, instead demonstrates an extraordinary capacity for balance within complexity. And beyond fire, water, and darkness, there are worlds caught in eternal winter, planets orbiting far from their stars, where temperatures plunge so low that atmospheres may freeze and collapse onto the surface as snow made of carbon dioxide or methane. Some may host thick layers of ice covering potential subsurface oceans warmed by internal radioactive decay. These frozen worlds remind us that planetary diversity is not simply a spectrum between hot and cold. It is a vast multidimensional landscape shaped by orbital distance, stellar type, atmospheric composition, magnetic fields, and geological history. What makes these planets truly mysterious is not just their extremity, but their persistence. Despite radiation storms, tidal forces, crushing pressures, and temperature extremes, they endure for billions of years. The universe does not seem to favor gentle conditions. Instead, it produces extremes, and those extremes remain stable in ways that challenge our understanding of physics and planetary science. Each discovery pushes the boundary of what we consider possible. Each new world forces us to ask whether our definitions of planet, of atmosphere, of habitability have been far too narrow. In the end, these planets of fire, ice, and darkness reveal something profound. The cosmos is not built around comfort or familiarity. It is built around physics, gravity, and chance. And when those forces interact across billions of years, they produce worlds that stretch the imagination beyond its limits. Perhaps the most intriguing mystery lies not in the planets we have seen, but in the ones we suspect are still hidden. Some planets reveal themselves only through subtle gravitational effects, causing their host stars to wobble ever so slightly. Others are detected when they pass in front of their stars, dimming the light by a fraction of a percent. Through these methods, scientists have begun analyzing the atmospheres of distant worlds, searching for chemical signatures that could hint at biological processes. Water vapor, methane, carbon dioxide. Each molecule tells a story about the planet's environment. In rare cases, combinations of gases appear that, on Earth, are associated with life. While this does not confirm biology elsewhere, it suggests that the building blocks for life may not be unique to our world. Yet the deeper mystery remains. How many planets are still invisible to us? There may be Earth-sized worlds orbiting faint stars beyond our detection limits, or rogue planets drifting silently through the galaxy, or even exotic types of planets made of materials we have yet to imagine. Some theories suggest the possibility of carbon planets, lava oceans spanning entire hemispheres, or even remnants of failed stars hovering on the boundary between planet and brown dwarf. With new telescopes and observatories scanning the sky with unprecedented precision, the next discovery could once again overturn our understanding of what a planet can be. The story of mysterious planets is ultimately a story about perspective. For centuries, we believed our solar system represented the norm. Now we know it may be just one configuration among countless possibilities. The universe is not constrained by our expectations. It creates worlds of fire and ice, of darkness and storm, of isolation and improbable balance. And as we continue to explore, one truth becomes increasingly clear. The strangest planets may still be waiting in the shadows, orbiting distant stars, silently challenging everything we think we know about reality itself.